Okay, now that we have looked at the different laws and theories that have to do with astronomy, we're going to look at some galaxies. So you don't need to write any of this down on this first slide. But before we talked about galaxies, I wanted to make sure everybody knew what a galaxy was. So all a galaxy is a bunch of different stars and dust and it's billions of stars within that galaxy. So when you look at the Milky Way, it's just dust and gas, and those gases are, like we talked about in nebula theory, hydrogen and helium, billions of stars, and I emphasize billions because that is a test question I have seen multiple times come up on the NCFE. They ask about if galaxies are millions, billions, or like thousands of stars. No, if you're ever answering that question, it's always billions, okay? There's a ton of different stars within the galaxy, and there are billions of galaxies as well. Hubble estimates 100 billion galaxies, but we know there's probably a lot more. That's just as far as we can see with our telescope. So galaxy is just a bunch of stars, a bunch of gases, and dust, and that's it. Yet they are very pretty. So there are three shapes of galaxies. The first galaxy shape we're going to look at is a spiral. And as you can see in the picture down at the bottom, a spiral galaxy, an example of that would be the Milky Way. So just like it says, it looks like a spiral. It, to me, kind of looks like an octopus spinning with its arms flailing in the water. And if you wanted to draw that, you could just draw a little squiggle and then little lines off to the side. So you've got your spiral galaxy arms extending out from the center, and it just goes around and around and around. This is what the Milky Way is, so a lot of times you do see questions about that simply because we live in the Milky Way. Now, another thing that I think is kind of neat, when you look at the Milky Way, if you're trying to think about where our solar system is within this galaxy, we are actually just randomly right about here. Well, if my pen would draw. It's not exactly where I'm marking it, but or where I'm going to mark it whenever I get the pen to work, but it's it's just on the outside of one of these arms. So right around there is where our solar system would be. So if you look at the entire galaxy, we are just a little teeny tiny speck out on one of the outer arms. So that is our spiral galaxy. Now we have two other shaped galaxies. One is elliptical. And just like Kepler's first law talked about, we know what an elliptical shaped galaxy is. We know what an elliptical shape is. It's simply something oval. So when you have an elliptical galaxy, it's just the oval shaped galaxy. And you could imagine this if you were looking at it in 3 dimensions as being something like a football in outer space. So your elliptical galaxies are going to be like a football, just more oval. And this is about what they look like. So we have one other galaxy shape. So we have spiral, we have elliptical, and our third and last one is irregular. Irregular is just random. There's no definite shape. There's just random stars just kind of everywhere. So spiral is going to be like the Milky Way. Nice, pretty, reminds me of a spinning octopus in the water. Elliptical is going to be oval like a football, and then you have irregular, which is no shape. It's not definite, it's just random, and those are your three shapes of your galaxies. Okay, so let's move right along. Hopefully you are done writing down everything. So how does the Earth move? I want you to just take a second and think of different movements that the Earth has. So most of you probably hit the main movements, the rotation and revolution. Those are the two that most students usually know about. And we are going to look at those. So first we're going to look at rotation. Rotation is simply the spinning of the Earth on its axis. So if you are going to stand in place and spin, that is what rotation is. So we're looking at the Earth, just stationary, but spinning around on its axis. One thing that I always need to point out is to make sure that people know about the Earth's axis. So the Earth's axis is right up here. It looks like a stick. You could think of a stake that is going through the North Pole, straight through the center of the Earth and out the South Pole. Now, don't confuse this with latitude. Latitude are the lines that are going up and around the Earth like this, but they are not going through the core or the center of the Earth. When we're looking at the axis, it's just a point of reference, but you would imagine it as if you got the like a stick and you poked it straight through the North Pole, all the way through the middle of the Earth, and it poked out the South Pole, which would be very unfortunate for Santa Claus and all of his reindeer if we were to do that. But that is the axis. Now, the axis is an invisible line. If you watch football, you may notice that there's lines that pop up with the different downs on the field. And maybe some of you didn't know this, but those lines are not real, okay? The axis is not an actual stick or going through the Earth. It's just a point of reference that we will talk about a lot. So as it's rotating, it's spinning along that axis, and it causes day and night. So when we spin to face the sun, that's daytime. And when we spin away from the sun, we're actually just in the sun's shadow, and that is what is nighttime. And that takes 24 hours. So when we're facing the sun, it's daytime. When we turn around from the sun, it's nighttime. And the reason it's so dark is because we're just in the sun's shadow. So that is rotation. Our next movement is revolution. So the first one was rotation, and that's how fast the Earth spins on its axis. Revolution is our second movement. Revolution is simply when something is orbiting or revolving around something. So if you're rotating, you're standing in place and you're spinning in place. If you are revolving, then that would be like if you stood up and walked all the way around your desk, or you walked all the way around the room. That's what we call revolving or orbiting. And so the Earth takes 1 year to make one full revolution around the sun. And if you remember from Kepler's first law, every orbit is going to be an elliptical or oval shape. So revolution is actually getting up and orbiting around something. And rotation is fixed. It's in one place. It's spinning in place around on its axis. The next thing we're going to look at is what shape is the Earth. So think about it. And you can say it out loud if you want. What shape is the Earth? Well, if you said a sphere, then I'm sorry, but you are incorrect, okay? The Earth is not a perfect sphere. Technically, I guess it is a sphere, but it's not a perfect one. The rotation of the Earth is actually going to cause the Earth to bulge out a little bit around its equator. So because the Earth is spinning so fast, it's forcing right around the equator, which if you remember where that is, and let me get the pen. Equator's right here. So because the Earth is spinning so fast, there's all this pressure being forced at the equator and it's pushing it out. So the Earth is wider at the equator than it is around the prime meridian. And so what I want you to do is get the yarn that's in the middle of your desk. Each one of you should be able to get one piece. And if your yarn doesn't work, you could always get your lanyard. Hold it at both sides, and I want you to spin the yarn in a circle. So to give you a little bit more clarity on what I mean by this, let's say this is you. Happy you because you love earth science. So hold your string up, and let's make the string blue because that is my favorite color. So you're going to hold the string or your lanyard straight up like that. So then you are going to spin it within your hand, so that's going to spin out, and you're just going to spin it from side to side. So as you hold the string like that, hopefully you understand what I'm saying. And as you spin it really fast, you should notice that it's going to bulge out around the sides of it. So as the string is spinning, it's going to go out like this and out like this. So the sides are bulging out as you spin it. So just like when you spin that string or you spin your lanyard, the sides bulge out because of how quickly it's spinning. That's what the Earth is doing. The faster the Earth spins, the further it pushes out on the equator because of gravity.